Hey, Vlad here, devinside.com. Welcome to the last video in the Git series. Today we're going to talk about conventional commits, which is not only a way to format your commit messages, but also an entire ecosystem of tools related to versioning your software and communicating those changes to the rest of the world. Let's get right to it. Before we begin, I would like to mention that technically this video goes beyond Git, and so I would like to congratulate you for completing this course. You are a local Git hero now. Alright, now our story for today begins in 2011 when Tom Preston Werner, a co-founder of GitHub, came up with a suggestion for naming the versions of your software. We're not talking about the commit messages, we're talking about the tags, or what GitHub calls releases. I'm recording this video in the early 2021, and I'm happy to report that this suggestion became one of the most widespread conventions in our industry. His suggestion revolved around the stability of the public API of your project. If it's a library, your API is self-explanatory. If it's Java, it's some interfaces. If it's C, it's some header files. If it's some web project, if it's the backend of that web project, then your public API is probably exposed over HTTP or something similar. If it is the front end of your web app project, then the API is the actual elements on your website, like buttons. Now, not every change of your project affects, or I should say, breaks the public API. But if it does, then those changes will for sure affect the experience of your users. For this reason, this suggestion that eventually became a convention is called semantic versioning, or short, semver, and you can read more about it on semver.org. There is some depth to this convention, but the TLDR is as follows. You always have three numbers separated by dots. A change that fixes a bug and does not break the API increments the last number. A change that introduces a new feature but still does not break the API, which means it introduces this new feature in a backwards compatible manner, increases the middle number, which causes the last number to be reset to 0. And if your change finally does break the API, then you increment the first number, which in turn causes all the other numbers to be reset to 0. Again, there are some details that I don't want to get into because this is not important to us. This video is not about semantic versioning. For example, you could have alpha versions, or you could deviate from this convention when you're still at the 0.0.0 versions and so on. Now, I've talked about semantic versioning for a bit, but I haven't actually explained why it is important. The reason lies in the purpose of versioning in the first place. A version is like a fingerprint of your software. It denotes the fact that something changed. Semantic versioning goes a step further and allows you to estimate how big that change was. This way you can make a judgment call whether to upgrade to a new version of a library or not. Nothing is guaranteed, of course. After all, it's just a convention. Did the last number change? Easy decision. We should definitely upgrade. Did the middle number change? It's probably going to be fine. Do we really need the new features? If we do, let's try it out. It's probably going to be fine. Did the first number change? Well, son, you better have some decent test coverage. Let's have an example, shall we? If we run git version, we're going to see that it's 230. And if we run update, which is this one, let's go and do this. I'm going to cut it out from the video because I don't want to waste your time. So let's run git version again, and we're going to see that nothing updated. And this is the reason why I actually don't like to use repositories. Git 230.1 was released a long time ago. In fact, if I go over here, we're going to click on release notes, and we're going to see that there will not be that much, right? So it's zoomed in, but it's like 5 changes or something, right? Because we know that it's just a bug fix release. So I'm pretty sure that it's even going to mention the word bug or fix. Yeah, fixes, blah, blah, blah. Okay, so, but if you go to 2030.0, which was a slightly major release, then we're going to scroll down. We're going to see a bunch of stuff was introduced. Okay, semantic versioning works. Let me mention a couple of more things related to semver. Semver is a convention that heavily relies on developers' discipline. For instance, in the Scala ecosystem, we're starting to have a couple of tools that are trying to help you out. They're trying to figure out whether you have broken source compatibility or binary compatibility, but none of them are bulletproof. Another thing to note is that in practice, for some reason, a lot of open source projects rush out the stable versions, and then literally within hours or maybe sometimes days, bug fixes are starting to roll in. I really don't understand what the rush is. Can you just be water, my friend? And one last thing to know about semver is that even though this is probably one of the most widespread conventions out there, there are actually alternatives. For example, in the Haskell world, there's a thing called Haskell Package Versioning Policy, or PVP, that you can check out over here at pvp.haskell.org. Now, before we go any further, I would like to note how important conventions and standards are. The more we have, the less time do we waste on bike shading. But more importantly, same as abstractions, aka naming things, breed more abstractions, conventions breed more conventions. And so today we're going to learn about a convention to structure your commit messages, which is based on semantic versioning, which is also the reason why we just spent a lot of time talking about it. Afterwards, we're going to talk about conventional changelogs, which is the ability to A, generate a changelog based on your conventional commit messages, B, automatically increase the version and maybe even commit it, and C, tag it on CI, and maybe even D, which goes beyond this video. We could even start some CI processes based on that. But again, this goes beyond this video, so we're not going to do it over here. Now, one thing to note before we start with the conventional commit messages is that they don't change the native Git commit messages guidelines. They just add structure to it. As a reminder, the native guidelines are as follows. The first one is use the imperative tone. So use things like add and update instead of added and updated. Start with a lowercase and don't end with a dot. It's not sentences, which is also why the imperative tone is used. For instance, add DB migration or update docs or fix bug 1337. Another reminder, these guidelines are only valid for the summary portion of the commit message. In the body of the description, you can do whatever you want. I prefer to write out entire sentences or even paragraphs. All right, let's finally talk about conventional commits. Conventional commits came from the world of front-end web development. To be more specific, they came from the contribution guidelines to the AngularJS web framework. Let's actually go to conventionalcommits.org, which I have over here. And by the way, notice it even has semantic versioning in the URL. It's very, very simple, so we're going to go through the website real quick. All right, this is a specification for adding human and machine readable meaning to commit messages, and it's very, very simple. It's just a couple of lines, even though the website, you can scroll a little bit. Okay, it says the conventional commit specification is a lightweight convention on top of commit messages. It provides an easy set of rules for creating an explicit commit history, which makes it easier to write automated tools on top of. This convention dovetails with semver by describing the feature fixes and breaking changes made in commit messages. The commit messages should be structured as follows. You specify the type without the Angular brackets. It's just a type. Now there is a set of types which is over here, but you can also add your own. The most important ones are feature and fix. Afterwards there is a colon, and in between you might add an optional scope. For example, if you're working on, I don't know, user analytics, you can put in the braces, you can put user analytics. Okay, and then space, and then you have the description, which is the summary portion of your commit messages. Again, Git guidelines still apply, something like add new feature or update this and that thing. Then you have an empty line, and then you have an optional body, which is the body of the commit message. This is the one where I use regular sentences or regular paragraphs. And optionally, you can have a footer. In the footer, you will either denote the breaking change, right? So you're going to spell it out in the capital letters, breaking change, or you're simply going to add even more notes, like for example, fix the bug number 137, right? Some Jira ticket or some Jira or Clubhouse or what have you. Now you can read through this in peace, but the TLDR we actually just went through. Please remember a couple of things. There has to be a colon over here. It's very, very important. Also the scope, it has to be a noun, which is not super important, but it's a part of the convention. And also whenever you break a change, right? So we have whenever you break a change, whenever you have a break and change, when you're specifying in the footer break and change, you also what you also can do is you can also put an exclamation mark, I believe over here or over here. In fact, I forgot, append after the type or scope, right? So it would be over here, right? So the way it works is that if you add it over here, you must have the break and change below. But if you specify in the break and change below, then this thing becomes optional. Now, if this is the first time that you're looking at this, it sounds very complicated maybe, but it's actually very, very simple. Here are a couple of examples. For example, you have a feature, so you have feat, which is a type, then you have a colon, you have a space, then you have your imperative message, allow, blah, 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 then space, you know, the body is optional, so you have break and change, colon, space, and then you have, you know, you describe what you have broken. Or for example, this thing over here, message was this to draw attention to the break and change. In fact, I believe I might have explained this wrongly before. So if you have this thing, then you don't need to specify break and change like this. So it was the other way around. Okay, so in this one you have both. You have like this thing, and you also have this thing. Technically, if you refactor stuff, you actually can't break stuff. Like as soon as you break stuff, it's not a refactoring anymore. Commit message was nobody. Like this is the one that you're going to use most of the time. Just added some dogs. Feature, you specify a scope. For language, you know, add Polish language. Technically P should be capital. Right. So this is like the full-blown one, right? So you have a fix, colon space, your summary, your actual commit message. I actually don't believe that there should be a space over here. Yeah. So if there is a dot, then this should have been capital if you want. You know, if you're creating a convention, you know, you might as well be thorough, right? Reviewed by somebody references this, right? And this is the details of the specification, but we actually don't really need to get into it. Like somehow they managed to come up with 16 points, right? And there is an FAQ and stuff, and you can go through it in your own at your own pace. And there are a bunch of tools. We're going to go through a couple of tools in this video, and that's pretty much it. This is the conventional commits. Let me scroll back up. Cool. So now this is a very, very simple format, but when you're starting out, chances are that you're going to make mistakes. Luckily, there is a bunch of tooling already built for you around this to help you out. And since it comes from the world of front-end web development, all of these tools are written in JavaScript, and so you need Node.js because you need something to interpret this JavaScript. We're going to see a couple of tools today: a linter, a commit message generator, a conventional changelog generator, and also a conventional changelog generator that also commits it and creates a tag for you. Let's start by installing Node.js. Now, a couple of videos ago, we set up the environment for a Scala project, and we use GraalVM, and GraalVM actually comes with a node and npm. So if we do which node, or if we do where node, where is a functionality that comes from ZSH. I have a couple of awesome videos about ZSH. You might want to check it out. So the versions are a bit outdated. So if we do this and if we do that, so these days the stable versions of Node is 14. And so we're going to go and we're going to, actually I haven't done which npm and where npm. Right, so we're actually going to go and use one of my install scripts to install Node. So we're going to go over here. We're going to do Node. As always, we're going to copy the 2 lines from here, and we're going to look into the script real quick. Right, so it basically installs Node.js 14. All right, so let's paste it over here. Let's press enter. Let's enter my password. There we go. Okay, as a reminder, I have videos about ZSH. You might want to check them out because this where thing, it actually shows you all of the installed ones and not only the one that is the first on the path. So for example, if I go out now and go back in and I do which node and I do where node, you're going to see that now I have a bunch of them, but this is the one that I have in the class path. The same thing for npm. Right, so again, where it comes from ZSH. All right, so node version is this, npm version is this, version like this. All right, great success. All right, so the first thing that we're going to install is a commit linter, and we have quite a few things to type out. And so I prepared a thing for you where I summed it all up. It's going to be down in the description, which is over here, conventional installation instructions for Ubuntu. Okay, so these are pretty much all the things that we're going to do today. Okay, so the first thing is to install Node.js, and now we're going to install Commitlint. In fact, I'm going to start copy pasting things from here. Okay, so we're going to install the Commitlint, which is a CLI tool, and we're also going to install this config conventional, which is an adapter. Okay, so conventional commits, they have a couple of different adapters, so there are technically a couple of different versions of conventional commits. We're going to stick only to the defaults, and I highly recommend that you also stick only to the defaults. And so the majority of the tools that we're going to install is going to look like this. So we're going to install the tool, you're going to install the adapter, and there's going to be some config where we're going to connect them to each other. Okay, so let's go and install two of these tools. We're going to install them globally. One of the things that you should probably know that if you're running a Node.js project, then a lot of these tools are set up in such a way that they integrate really, really well with Node.js projects. So you don't need to install them globally, but since this is mostly a Scala channel, we're going to install them globally. Over here, we're also going to have the configuration files globally so that we can use it in any directory. But even if you're not in a Node.js project, in practice, you should probably have the configuration files inside of your repository so that all the developers use exactly the same configuration. All right. Okay, so let me copy these two lines. Let me go over here, paste them, enter my password. Come on, there we go. Actually, I'm not sure if it understood that I pasted two of them. In any case, I'm going to speed this up in the post-production. All right, let me actually paste it again so that I'm sure that I installed both of them. Yeah, it didn't. So this is the CLI, and this is the actual adapter conventional changelog. There we go. Okay, so now we have both the CLI and the config conventional adapter. Okay, so we're going to go back over here. We're going to copy this line, which just puts this string into this file, and that's all it does. All right, so we're going to do this, and in fact, we're going to see it. Commitlint rc. There we go. So this is what we just put into this file. All right, so now what we can do is we can pretend like we're having a commit message, for example, add export button, and we can simply pipe it into Commitlint like this. All right, there we go. It says input, add export button, subject may not be empty, type may not be empty, found two problems, blah, blah, blah. And then you realize, oh, I actually forgot to add, something like this. And now it says, it's all good. Okay, you can also do something like this. I should probably use the regular quotes. Doesn't like me like this. There we go. Oh my god, what happened here? Like this, like this, like that. All right, yeah, so this one is fine. You can also do something like, I don't know, user analytics. So all of these are fine. Now, commit linting is great. This is your first line of defense, but to be fair, this is probably rather a tool that is going to run with your continuous integration jobs. So locally, you're probably not going to use it that often. In fact, we will use it locally. We're going to put it into one of our Git hooks. Git has a concept of hooks that we're going to learn about in just a couple of minutes. But the other tool that you actually will use locally is going to be a commit generator. And it's going to make you a great commit citizen, which is why it is called Commitizen. The same deal, we need the tool and we need the adapter. So we're going to grab the tools, paste them in over here. I wonder if it actually pasted both of them. Again, like pasting multiple lines is sometimes tricky. And now the adapter. In the meantime, I'm actually going to go over here. I'm going to grab this line. And again, my script over here mentions that feel free to use a target local to your project, right? So you can create a .cz-rc in your directory, okay, instead of in your home directory. Okay, it's finished. So let's do this. Let's actually look into it. All it does is it specifies the path to the adapter. All right, now let's actually create a repository so that we have something to play around with. We're going to create a conventional playground, and we're going to call it repo. We're going to do ginit, and we're going to echo some stuff into a file. And as a reminder, there is GAA. So we're going to add, right? And now we're going to run cz, right? So cz is the Commitizen tool that we just installed. I'm going to press enter, and it's going to present us with this thing. It says over here, use arrow keys, but you can also use J and K. You cannot search. I'm pressing J, and it just keeps scrolling. As you can see, there's chore, revert, feature, fix, dog, style, refactor. Okay, so let's say that this is a feature. So I'm going to press enter. Okay, what is the scope of this change? Again, it's optional, so you can just press enter, but we can also do user analytics, for example, like this. Write a short imperative tense description of the change. So, for example, we can do add new feature like this. And as you can see, I use the sentence. Commitizen can actually recognize a couple of things, so it will lowercase the a for me, and it will remove the dot. However, it's not bulletproof, so if you have something like an exclamation mark, it's not going to notice this. Okay, so it's just going to remove the dot, and it's going to lowercase the a. Okay, longer description. This is a longer description. Are there any breaking changes? So if you want to press no, you can just press enter or type in N. I'm going to say yes, and it's going to say describe the breaking change. Well, I broke everything. I broke everything, like this. Does this change affect any open issues? Well, yes. So I fixed number 1 to 3. There we go. All right, so now if we do something like this, we see that we have, feature, user analytics, colon space, add new features. And if we do git show, it's going to say all of these things. So it created exactly what we have seen on the conventional changelog website. Now, it is actually important to understand the architecture of this Commitizen tool, because actually the most power is in the adapter. For instance, you could change the adapter to use emojis instead of these topical words. And then not only it's going to replace these topical words with the emojis, but actually the entire prompt that we just went through is actually going to look very different. Now, a big note about this, if you're changing this, then you should also change the adapter for the linter because it needs to understand the emojis. Okay. Also, I highly recommend you not to use emojis because even though they look really, really cool, in my experience, every time you're doing something special, you run into issues in the end. And another thing that I should probably mention, don't start using any of that stuff, especially the emojis in your project before you talk to your team. Okay? All right, let's go over here. And so we're going to grab the emoji one like this. Okay, and I'm just going to paste it over here. So while it installs, I'm just going to copy this line. As you can see, it pastes pretty much exactly the same thing into cz-rc. It's just going to use a different adapter, right? So the path is just going to change. Okay, so it almost finished, and there we go. I'm going to paste this. So let's go verify cz-rc. There we go. Okay, so what we need to do now is we need to pipe something else into the file, add everything, and run cz, and now it's going to look slightly different. First of all, there is emojis, right? It says like you can use the arrow keys, but you can also type to search, right? So for example, in this case, I'm going to say feature again. So I'm going to type in FE. There you go, feature. This is going to be the emoji, right? The rest is going to be similar, but not the same. Specify a scope. Let's do user analytics. Okay, write a short description, add new feature, and enter. And I'm not going to do that. Over here, for example, it says a breaking change commit requires a body. Please enter a long description of the commit itself. But I didn't tell it that we actually broke stuff. So it actually assumes that if you didn't break stuff, that you're just going to press enter and it's going to let you through. Okay, list any issues closed. Nah, I don't have anything. All right, so if you now do this, we're going to see that it used sparkles over here, right? So this is Gitmoji, and I should probably show it to you. Gitmoji is over here. So some dude picked up a couple of emojis that sort of fit into your fit into programming. For example, if you fix a bug, it looks like a bug. If you have, sparkles, it introduces a new feature and so on. And these are going to be rendered by Git, but they're not going to be rendered in your terminal. And so what you can do instead is you can go and you can configure cz-emoji adapter. Right, so I'm just going to grab this. As you can see, it starts with the same thing, right? Pass cz-emoji, but then it adds the config. Okay, so we're going to open cz-rc. Okay, and we're just going to delete this and paste that. That's not what I wanted to paste. Delete, and paste that. There we go. All right, and so now what we're going to do is we're going to echo even more stuff into the file. Then we're going to do cz. Okay, same thing. Let's do feature. Let's do user analytics. Add new feature and enter. We don't really care. Oh, I forgot to edit. Okay, cz. Okay, feature and user analytics and add new feature and enter, and there we go. Okay, so now this one is actually rendered properly, but notice that technically the original conventional changelog format was very clear about a colon over here, but this is a different adapter, so technically it's a different format, and for some reason it doesn't have a colon. I have a theory why it doesn't have a colon, because the original Gitmojis, they actually end with a colon, but still the colon should be over here, so yeah, no idea. Again, as a reminder, if you want to actually use it, then please also adapt the linter. And where do I have it? Here, changes to the Commitlint, right? So this is a link to this section over here. This is a section of the Commitlint. In fact, let me enable this. I hate it when it jumps around like this. Okay, so essentially you introduce a new adapter and you put the configuration in there, and it's going to lint your emojis as well. All right, so we're actually not gonna use emojis, so I'm actually going to revert this to the conventional commit. So I'm gonna, to the regular one. So we're just gonna do this. There we go. As a reminder, I don't recommend that you use emojis. For example, first thing you need to do, you need to change the linter. Second thing you need to do is you need to decide whether you want to use Gitmoji or Unicodes. Third thing that you're going to realize is that the Unicode characters are not rendered in all the terminals equally. Sometimes they are not rendered in tools. By the way, if you have the Gitlands extension in Visual Studio Code that I have showed you in the previous video, it shows you the Git blame, and it actually understands both the Unicode characters and the other ones. So as you can see, you can actually see it here. It actually understands Gitmoji as well. I believe if we go back, well, in this view it doesn't show it, but you get the idea. By the way, one thing that I kind of jumped over is that if we just went to using the conventional commit, we could have just changed it over here. We could have left the config. It's not a big problem if you have the config for an adapter that you're not using, right? Let's go back.